Okay, so this is the lesson that isn't as hard as some of the other ones, but it has the weirdest name. Multiplying a polynomial by a monomial. The first thing you're going to ask is, what the heck are polynomials and monomials? And in fact, I think that's a lot of people's problem with math, is that honestly, the words we use, you get confused and it sounds harder than it actually is. A polynomial is just something with more than one term. A monomial is something with one term. Why do we care? Well, sometimes we want a relationship that doesn't start at step 0. Okay? So for example, the one that we did on Monday, it doesn't actually start until step 2, because it starts at 2, and then it goes up by 4, but it doesn't start going up by 4 until step 2. So it'd be really nice if step 2 were actually step 1. If we could just shift it back one side. And the way we do that is, instead of having it be 4 times x, we make it 4 times, and put in a bracket, x minus 1. We literally do shift it back by 1 before we multiply it by 4. So that way, when x is 1, this becomes 1 minus 1, which is 0, so we just get 2. If x is 2, y is 2 minus 1, which is 1, times 4 is 4, so we get the 4, and then add the extra 2, and then we get 6. Or if we put in 3, it's 4 times 3, minus 1, which is 4 times 2, which is 8, plus 2, which gives us 10. All right, so that actually makes it a little easy. So we can basically, instead of having to figure it out, we can shift what step we're on. The step can be arbitrary. But that creates multiple terms. So monomial. Mono means 1. So anything we say the word monomial, it's a fancy way of saying there's just one term. So 5x, x squared, 4x cubed, 3x. Okay, if it can be a number, it can be a variable, or it can be a number times a variable. Okay, and the variable can have any exponent. You can even have a negative, and that just means the number is minus 3 instead of the number being 3. Poly means many. So polynomial, when we use that fancy word, we're just saying it's more than one term. So, for example, 3x plus 2. There are 2 terms, or this one, 2x squared plus x plus 3. There are 3 monomials, 3 terms that we have to take into account. And why do we have to do that? Well, when we're using variables, we can't add terms with different values of x because we don't know what x is, and because we have to multiply before we can add, that whole order of operations thing, we can't do it. I can't add that without knowing what x is. So that's why we have to leave it as a polynomial. We can't make it any simpler. Now, the trouble is sometimes you want to multiply polynomials together, or you want to multiply a polynomial by a monomial. So, look at the example we had, right? This is kind of confusing. 4 times x minus 1, it's got a bracket we want. Maybe if we could get rid of the brackets, it would be a little easier to understand. But how do we multiply the number by the bracket? Well, you do that the same way you always multiply a number in a bracket. Everything inside the bracket, all the terms have to be multiplied by the term outside. So, in this case, we have to multiply x by 4 to get 4x, and we have to multiply 1 by 4 to get minus 4. Remember, the 2 just stays the same because it's not in the bracket, so it's not multiplied by that 4 at all. So, we get 4x minus 4, don't forget the minus sign, minus 1 times 4 is minus 4, plus 2. Now I can add the terms that don't have an x, because minus 4 and plus 2, that's just minus 2. So then I end up with a simpler form. It looks back to the way that we like to have the equations, where it's 4x minus 2. And if you plug that in, the steps, you'll actually get exactly the same numbers. 4 times 1 is 4, minus 2 gives us 2. 4 times 2 is 8, minus 2 gives us 6. Because this and this are exactly the same. We didn't change it by multiplying. It's the same equation. All right, so if we're multiplying by a number, numbers only multiply numbers, variables only affect variables, okay? So if you've only got a number outside, you just multiply it by the numbers in front. So 4 times 2, 8. The x squared stays the same. 4 times minus 3, minus 12. The x stays the same. 4 times 6, 24, and there's still no x. So we multiply the 4 by the 2, the 4 by the minus 3, and the 4 by the 6. Numbers only multiply numbers. If we've got a variable, it's exactly the same. Variables only multiply variables. And when you multiply a variable, something neat happens, right? Like x times x, well, x is actually x to the 1. And sometimes I actually like writing it like this when I do this, so you can actually see that it adds. So x squared actually means it's x to the 1 times x to the 1. You're actually adding the exponents. So when you multiply variables, you add the exponents. So you get x squared. So if we multiply x by a number, it just becomes that number times x. It doesn't change the number. 4 times x is 4x. We usually just put the number first, just so that it all looks the same and it's easier to see. So numbers only affect numbers, variables only affect variables. So let's say I multiply a polynomial in a bracket by x. Well, the x doesn't change the 3, so it's just 3. Then I get x times x squared, which is x to the 1 plus x squared, which would give me x to the 3, x cubed. The next one, x times 2x, doesn't change the 2. You get x times x, which is just x squared, 1 plus 1. And you get x times 6 is minus 6x. It doesn't change the number, doesn't change the negative. It just adds an x onto the end of it. So what if you do both? Well, if you do both, you just multiply the numbers by the numbers and the variables by the variables. So you multiply the numbers and add the exponents of the variables. So 4x, by the way, one thing I found really useful when I was learning how to do this was I kept making the mistake that I'd have trouble adding when it didn't have a number. So x is always x to the 1. So when I would do this, I would actually always write x as x to the 1, just so that when I multiplied them, it'd be easier to see that I was adding 1 and 2. That's why I'm getting 3. Otherwise, you get confused as to why did nothing plus 2 become 3. Well, this isn't nothing. This is actually x to the 1. And to me, that just conceptually helped me understand a little better, and it helped me get these right. So let's multiply this. So you have to multiply 4x by each of these terms. So we start off with the first one. 4 times 3 is 12. X times x squared is 1 plus 2. That gives me 3. My exponent's total is 3, so that's 12x cubed. 4 times minus 2x. Well, 4 times minus 2 is minus 8. X times x is x to the 1 plus x to the 1 is just x squared. 4 times 7 is 28. X times nothing just gives me an x. Don't forget that you still need the x, okay? By the way, this is the one thing that once you start doing it, you're going to get better at, and a lot of you will be able to just do this in your head and go from here to here. So as soon as you're able to do that, I don't need you to write steps. If you're making a lot of mistakes, I would still recommend writing the steps. But once you get comfortable, literally, I don't need to see any steps in between, okay? Even if you're more comfortable just going from this to the end, or from this to that to the end, whatever works, okay? I'm just writing out every conceptual step to sort of help people see what's happening. But this is the one thing, once you get the hang of, it'll make sense. All right? So, takeaway from this lesson. When you're multiplying, every term in polynomial means more than one term. Monomial means one term. When you're multiplying them, you multiply the number, then you multiply the numbers, then you multiply the variables by adding the exponents for every term inside. Another thing I found helped was I would actually draw a little arrow between the 4 and the 3, and the 4 and the 2, and the 4 and the 7 to remind me that I had to multiply by every term inside by 4x. This is really one case that once you just slow it down, take it easy, it'll make your life a lot easier, okay? Just go slow, be careful, be meticulous. All right? That's it. Good luck with the worksheet. Please contact me if you have any trouble.